Good afternoon and welcome to the security seminar with CERIAS at Purdue University. Our speaker today, the first of the fall semester, is Scott Hollenbeck. He is the Director of Applied Research at Verisign. His topic today is provisioning protocol challenges in an era of GTD expansion. Explain to us what that is.
Sure, glad to. Provisioning protocols. What we're talking about are protocols used to register domain names. All right, and if you're thinking domain names, what's that? Purdue.edu, Amazon.com. There's a protocol used to register, provision, and manage those domains. I was the author of the protocol that's being used today, and a little bit of background information that we'll get into in a little bit more, a little bit further. You have to remember what the purpose of a client-server protocol is. It's an agreement between the client and the server. It's the language they use to communicate, right? And deviations in that language can present challenges. So, having said that, what do we talk about here today? First, I'll give you some background information describing the domain name system itself. I don't want to assume that you all are DNS experts, so I apologize if it's a bit of a review for some of you, but it'll help set some important background information. We'll talk about an entity called ICANN, or the Internet Corporation for Assigned Names and Numbers, and gTLD expansion. What are gTLDs? It's an acronym that stands for Generic Top-Level Domains, and what do we mean by expansion? We'll talk about registrants, registrars, and registries, three words that sound very similar, but they are indeed very different, and their role in the ecosystem. And then we'll talk a little bit about the Extensible Provisioning Protocol. Okay. We'll then talk about the challenges facing the partners in this ecosystem. EPP was written and specified using XML. The X in XML stands for extensible. Right? We'll talk about the new gTLDs, the process that's being used to introduce them, and new operating requirements. We'll talk about the interfaces used by registries and registrars, and then in all cases the challenges faced by each of these elements. We'll talk about the steps being taken to address the challenges, and then finally some summary and conclusion statements. Any questions before we proceed? Okay, and just as a mechanical point, rather than waiting until the end of the discussion, if you have a question at any time, just raise your hand. I'd like this to be as interactive as possible. It's really boring for me if I just have to stand up here and push through buttons and talk to slides for the next hour. So please engage me. Okay, so first let's talk about the domain name system. You'll often hear it described using the acronym DNS. It's an inverted hierarchical tree structure with a root. So if you ever see a picture of the DNS, described graphically, you'll see a point at the top. That's the dot, that's the root. It's served by servers. Okay, they're called root servers. There are 13 of them. So what sits on a root server? The root server holds information describing where you find the next layer under the tree. Right? And that's really the case for each layer of the tree. It describes the next layer down. But the way this works practically, if you're sitting at your web browser and you're trying to find Amazon.com, you may not realize just how much background communication happens to make that work. The very first thing that your browser will do is it contacts something called a resolver, a DNS resolver, which receives the question from you. You're saying, how do I find Amazon.com? Right? Remember, that's a name. Protocols don't deal with names too well. They like to deal with addresses, numbers. And in this case, we're trying to translate Amazon.com into an IP address. All right? So there's a couple different players involved. The first thing the resolver needs to know is, well, where do I find the name servers for .com? And who do you think that it might ask? It asks the root. That's the single source of truth. So when you always have to ask, well, who do I start with first? You start with the root. Okay? Given that there are 13 servers, the one that you query tends to depend more on where you're physically located and which of the servers tends to be physically located nearest to you. DNS software tends to be smart enough about querying the servers with which it gets the best response times. And a lot of times the implementations have algorithms to adjust the partnership relationships dynamically. So for example, if one of the servers tends to go down, it's one you've talked to before, you're not going to be dead in the water. it'll simply say, oh, okay, that server's down, let me try the next one. And because there are 13, they're well known, it's not hard to find an alternative. And notice I said that there are 13 servers, but there are only 12 operators. Verisign runs 2 of the servers. All right, and just in case you're wondering, who's Verisign? Maybe you think that we operate the telephone system for your mobile phone and whatnot. No, we're a different company. We're not Verizon. In some ways, some of you are probably too young for this, but you may remember there were commercials for a company called BASF, where they had commercials for products that were kind of like, we don't make the blank, we make the blank better. And that's kind of what Verisign does. We work in the background. We're an internet infrastructure company. We don't do retail sales, so we don't have a lot of direct contact with consumers, but we do a lot of business-to-business work. So we operate 2 of the root servers, okay, the A server and the J server. They're identified by first letter of the alphabet. Like, so you have the A server, the B server, the D server, like that. We also operate the registry for .com, .net, .name, .edu, .jobs, .cc, and .tv. So a couple of generic top-level domains and a couple of country code top-level domains. So I just gave you a couple of terms I haven't described yet, so let's step down a little bit further. Okay, under the root, you have generic top-level domains, and so when you think of com, net, edu, those are called generic top-level domains. You have infrastructure top-level domains, and right now there's only one. That's .arpa. You've got country code top-level domains. Every country has its own. So there's .ca for Canada, .us for the United States, DE for Germany, and so on. You've also got a very small number of reserved top-level domains that don't necessarily actually appear in the root. TLDs like example. And these are typically used when you're writing protocol specifications. You have to give examples, but protocol designers are loath to use real TLDs in specification papers because things change. A TLD that's here today may not be there tomorrow. These are reserved. They're always going to be there, and you don't ever have to worry about them going away. And then very recently, you've also got an experiment that's being done in internationalized top-level domains. As you might imagine, if you're not a native English speaker, or if you happen to write a language that cannot be represented using ASCII characters, the current domain name system doesn't necessarily port very well to places like India or Russia. You see something .com, and if you don't know what those characters mean, and particularly if it's not even on your keyboard, well, how do you get there? How do you type these names? And so in the last several years, both people in the Internet Engineering Task Force and the Internet Corporation for Assigned Names of Numbers have realized that to make the Internet more usable to everybody around the world, particularly non-English speaking people, you have to make it reachable, and you have to make it understandable in the language that they're familiar with. So there's an experiment underway right now to take a relatively small number of top-level domains. So for example, you'll see the example I've got here. I unfortunately don't exactly know what that translates to, but this is what a Russian top-level domain name looks like using internationalized characters. Okay? It's using characters from the Cyrillic keyboard, and this will actually resolve. Okay, so a little bit about gTLD history. Prior to 2000, there were a very small number of top-level domains, generic top-level domains, that is. You had .com, .edu, .gov, .int, .mil, .net, and .org. And originally, these were set up for sort of specific purposes. .com was designed to be for commercial entities, .net for infrastructure entities, .org for non-commercial entities, .edu for educational institutions, .mil for the U.S. military, and so on. But as you might imagine, over time, the space got a little bit crowded, and people were saying, ooh, there's no more domain names available in .com, or perhaps we'd like there to be some competition to .com. So from 2000, you started to see a couple of more experiments in adding top-level domains to the root. And there's a very small number that got in the very first pass, including .aero for the aerospace industry, .biz, which was intended to be a direct competitor for .com, co-op for cooperative institutions, info. I think their whole purpose was just informational types of domains. museum for museums, .name for personal names, and .pro for professionals, lawyers, doctors, accountants, things who had people who had professional certifications. Okay, so this was the first experiment that ICANN conducted. Whether or not it's successful is a matter of perspective. So, for example, .biz, it was intended to be launched as a direct competitor to .com. They've got about 1 million domain names in .biz. .com is approaching 100 million? A lot more. Okay, so starting in 2004, ICANN branched out a little bit. They said, well, let's try a couple of other experiments, primarily in sponsored top-level domains. Sponsored top-level domains are not intended to be these repositories with billions of names underneath them. They're intended to be used for very specific communities of interest. So in this case, they approved 6 new domains. The first of which was .asia, .cat for speakers of Catalan in Spain, .jobs for both people posting jobs and for people looking for jobs, .mobi for the mobile telephone industry, .tel for the telephone industry. They were actually looking to publish telephone numbers as domain names, and .travel for the travel industry. Okay, so again, the experiments were generally successful. People were proving that you could add new domains to the root. The world did not end. Nothing broke. But there were a lot of people that were clamoring to still get into the space because they were saying there's still more demand. There still aren't enough alternatives to .com. We need more domains. So in March 2011, and this one in particular has been very interesting, ICANN approved .xxx. Does anyone have an idea what that TLD might be used for?
Would that be like a new word?
No. So you're not familiar with that, Christina? Okay. Those 3 letters are typically used to represent pornographic content.
Oh, that's one. Not XX. Okay.
Okay. All right. And the operator or the person that or the company that proposed this particular top-level domain had been pursuing this application for a number of years. They said, look, there's a real need for this. We think there's a burning desire. We would like to create this domain for this type of content. And so they had an application in with ICANN for a number of years. And then finally in March 2011, early this year, ICANN approved their application. And they're now currently in the process of going through figuring out what it takes to register domains and how to operate it. And as you might imagine, given the type of content, and it's a very controversial topic in many corners. But the more interesting aspect, yes, question. Push a button.
Is it working? Okay. Yes, you had mentioned that ICANN was experimenting and trying to see if things did not break down.
Right.
But why were the initial fears that it might break down if we keep on adding more domain names?
That was probably more of a perception than anything based on fact. Remember, the root zone is a zone like any other zone. And Verisign has proven for a number of years that you can operate a DNS zone with millions of names in it, and nothing fails or breaks. There were some people had thought that introducing new domains into the root might be a technical challenge. So part of the reason that ICANN wanted to do this on an experimental basis was to make sure that, no, indeed, this could work, and if it's done in a controlled way, nothing would break. But I think the bigger concern has more to do with things like intellectual property, trademark protection, brand protection, and the like. As you might imagine, Sony Pictures might not be very happy if someone else were to try to register a .sony top-level domain. And given the sensitive nature of some of those topics, it's taken a long time and it's been a very controlled, deliberate process. All right. So now where this gets more interesting, at least in the context of this discussion, is that very recently, in June of 2011, the ICANN Board of Directors approved a plan that would allow for almost, I don't want to call it infinite, but much greater expansion of the space. So starting early next year, people are going to be able to submit applications for additional top-level domains, and there's essentially no restriction on the numbers. There are other constraints that will come into play, and we'll talk about those in a minute. Right? So now, under the gTLDs, Under .com, under .edu, what do you have next? Well, you've got things like second, third, and, as I call them, star level domains. Purdue.edu is a second level domain. CERIAS.purdue.edu. Okay, these are all domain names too. They each have their own zone. Hi. And so on. Okay, so now let's talk a little bit about, Christina?
So I hope that this works.
Is
Push.
the green
Okay,
light's on, you're
yes.
good to go.
So, quick question before we move, because
Sure.
you were mentioning the
Let's go
root
back.
servers, which there are 13. I was curious if you can talk a little bit about how they are maintained consistent and what kind of protocols they're running.
Yes. Okay, as you might imagine, yeah, with 13 servers, consistency is an issue, particularly since one of the underlying truths of the DNS is that no matter who you ask, you get the same answer every time. The way the process works, you have an entity called IANA, who is responsible for submitting change requests to the root, so to speak. And typically the way that happens is IANA gets approvals from ICANN and the U.S. Department of Commerce when a root change needs to be made. They send instructions to Verisign. Verisign, now, historically the A root was considered the authoritative source. And so what would happen is a change would be made in the A root, and then it would then be perpetuated or copied from the A to the other 12 servers. That's essentially still how the process works. So we make the change, and then the other operators are all responsible for ensuring the
So
consistency.
that's why they contact you, because you're running the A server, right? You are running A and G.
Yeah, J has nothing to do with this. J is just another server like the others. And frankly, even these days, A is not considered the authoritative single source anymore either. It's more a matter of process at this point.
And just one additional question. How often are these changes? What
There's no regular schedule. They're infrequent. What happens more commonly are things like name server changes. As a country code top-level domain wants to retire a name server and replace it with something else, we end up having to make a change in the zone to reflect that. But it's very infrequent that new domains are added to the root. In fact, if you look at the chart here, there were some changes made in 2000 to add a few, a couple more changes in 2004. Country code top-level domains change when new countries come and go, which, as you might, does not happen very frequently. Thank you. Okay, so a little bit about ICANN. I've already expanded the acronym for you. It's the Internet Corporation for Assigned Names and Numbers. But if you're wondering about the history, it didn't exist prior to 1998. Prior to 1998, the way this all worked was you had, my former employer, Network Solutions. We got bought by Verisign in 2000, as it turns out. But Network Solutions had a contract with the U.S. federal government. We operated both the root, the A and J root, and we operated the infrastructure for .com. There was one registrar. If you wanted to register a domain name in .com, you had to come to Network Solutions. And you typically did that with a faxed piece of paper. You'd fill out a piece of paper, stick it on your fax machine. It would show up on a fax machine in Herndon, Virginia. Someone would pick it up, and then they would go key something in, and you had a domain name. And of course, after you're paying your bill, too. Domain names were not free, at least not in this time frame. One of the reasons ICANN was created was to help create competition in the domain registration market. Right? So one of the first orders of business was to separate the registry and registrar functions within Network Solutions and to create a number of registrars that would compete with Network Solutions to register to domain names. All right? And I've got a definition here. I'm not going to parrot that back. You can see what this is. ICANN's mission statement. Okay? So then what about the new gTLD program? And why is that important? Again, let's go back to that competition thing. If there's only one large top-level domain, people are talking about a need for choice, a need for more real estate. I can't register the domain I want because it's taken in .com. Okay, so you create new opportunities by creating new TLDs. This has been one of their topics of discussion since before they existed in 1998. So it's now 2011. It's taken them 13 years to get to this point. But it's 13 long years of discussion with people at all levels of involvement. I mean, this is, internet geeks, this is policy people, this is lawyers, this is trademark people, it's government representatives. And try putting all those people in a room and getting them to agree on anything is a major challenge. But after 13 years, they finally got there and they agreed, okay, now we have a plan to go forward. Approved on June 20th, and starting in January 2012, you can submit an application for a new top-level domain. There's no limit on the number of applications, and so there's thus potential for significant expansion. So how many of you thinking maybe you want to get in on this and submit an application of your own? Nobody? I didn't scare you off with that talk of politics, did I? Okay, well, here's another thing you might want to think about. There's an application fee, $185,000. All right, so if you want to write mom and dad and ask them to send you a check, go right ahead.
Buy a house for that money.
Yes, in some parts of the country anyway. All right, so you might be sitting there, you might be asking, well, why so much? You remember what I said a little bit while ago about trademarks and politics and all that stuff? Well, part of the application processing fee includes a very rigorous evaluation. They're trying to make sure that nothing gets through that's going to cause problems down the line. And so they've got evaluators, they've got attorneys, corporate attorneys, trademark attorneys, they're going to be looking at this, and these people all cost money. So there's the evaluation process, and the rigor of the evaluation process is why the fee is so high. All right, another set of terms I mentioned a little while ago: registrants, registrars, and registries. What are these three R's? Let's start with the first one. What's a registrant? People like you and me. If you have ever registered a domain name, right? If you've got your own little blog set up someplace or whatnot, you're a registrant. And notice I said this is a second-level domain name, okay? None of us as individuals can register TLDs at this point, but it's very easy for you to just, go to a website, whip out your credit card, create a new domain name, you're off and running. So who do you deal with as a registrant when you want to register a domain name? You work with a company typically called a registrar. This is the entity that provides the registration service to registrants, or some other entity that provides services to registrants. Some registrar companies work directly with individuals. Companies like GoDaddy. There are other registrar companies that work a business-to-business model. Who is one off the top of my head? Two Cows. I know I had that example here for a reason. There's a company called Two Cows, and they work with other businesses. Typically web hosting companies. So if you've ever gone to a hosting company and said, hey, look, I want to host my web server over here, they'll often offer you, hey, how about a free domain name or a discounted domain name? And they can do that because they've got a relationship with a company like a Two Cows. Okay? And the third entity are the registries. These are the companies like Verisign, Newstar, Filius, DENIC, Nominet. And what we do is we provide the provisioning service to the registrars. Right? This allows the registrar to take the information they have from somebody and put it in a place such that it's accessible to everybody else on the internet. Okay? And you notice I highlighted the words provisioning. All right? So provisioning, this is the publication of the information, the putting the information in a database, putting it in a zone. And resolution. Resolution's focused on the lookup side. So when you're sitting at your browser and you're trying to get to the Amazon.com website, somewhere there are servers translating those text strings into addresses. That's the resolution process. All right? So now how do these entities work with each other? The registrant-registrar interface is usually web-based via HTTP. So if you're talking to a GoDaddy, you're using HTTP to talk to GoDaddy. The companies that provide B2B services typically do something very similar. They've got some kind of a protocol that they're using. It's often web-based or something carried over HTTP. And they exchange information automatically. There's no more faxed pages anymore, thankfully. And the registrar-to-registry interface, whereas this used to be a faxed thing back about 10 years ago, nowadays it's automated via a provisioning protocol. And a provisioning protocol in this context, we're going to talk a little bit about the Extensible Provisioning Protocol, or EPP. EPP didn't exist prior to 1999. All right, you remember when I said that the way this worked with network solutions was faxed papers? That doesn't scale. In the context of adding new registrars and millions of new domain names, there's no security. What happens if the piece of paper falls off the fax machine into a trash can? Someone's not going to be very happy, right? It's not real time. I don't need to explain how bad fax papers are for trying to do this in a very timely, reliable way. So back then, I was working on the registration system for network solutions. We had a protocol called RRP, or the NSI Registry Registrar Protocol. We used that for a test bed with 5 registrars when we kicked off this whole registry registrar separation thing. RRP worked, but it had limitations. Okay, it was designed for use by NSI for NSI's customers. And when ICANN started looking at the possibility of adding new top-level domains, and remember, new top-level domains probably also meant new top-level domain operators or registries, the need for a protocol that could be used by all registries became apparent. Right? So I was sitting at my office one day saying, okay, this is definitely going to happen. It's something that we can either drive ourselves or we can get run over by it, because there were clearly people who wanted to get it done. So I took a couple months and wrote up a couple of internet drafts, and if you're familiar with how the Internet Engineering Task Force works, it's based on documents called internet drafts. The protocol specifications written in text form. The publication process is very easy. These days it basically boils down to push a submit button on a web page and it's available to everybody who wants to look at it. And then it's out there for public discussion. So after I crafted the first set of drafts, the challenge I had was in finding people who were interested in the topic. And it's about building consensus. It's about getting people behind your ideas and trying to push the idea forward. So my major goal when I started looking at this was, one, get the consensus thing going, but also focus on extensibility. Remember, different TLDs. What separates one TLD from another? The character strings are really irrelevant from a machine perspective. People give those strings semantic meaning. And people give those registries, those domains, meaning by offering different types of services. So rather than trying to design one protocol that would rule the world, if you're, let's use the Lord of the Rings analogy here, I tried to come up with a design that would provide the basic services required to make a domain resolvable. Everything else could be done via extensions. Right? So we tried not to get 50 people in a room to agree on, well, I think this trademark policy is the right one. That wasn't going to work. I mean, you can see how that kind of stuff was happening in ICANN, and imagine, again, a bunch of geeks who are, first off, clueless about how this stuff works in the real world, trying to reach agreements on how we think it should work in a protocol. No, we punt that part. So let's talk about the IETF a little bit. I'm really proud of the fact that it only took me 2 years to get a working group started. And if you think that sounds kind of funny, you clearly haven't spent any time working in the IETF. The IETF works in units of time measured in years, typically. Okay? So we had the working group started in 2001. It took us 2 years after the working group was started to get the very, very first proposed standard RFCs out the door. So now if you remember, though, these things first started in 1999. So 2 years post-working group, 4 years post-work started. But we had our first protocol specifications in 2003. And now remember how the time frame overlaps, though, with these new TLDs that came out in 2000 and 2004. Right? So some of these registries were operating at a little bit of risk. They were writing protocol specifications based on they were doing protocol implementations based on draft specifications. That's no fun when, again, you got a bunch of engineers sitting in a room saying, nope, I don't like that, change it. And some poor developer someplace is going, you just created 6 months worth of work for me, right? But somehow we muddled through it. Now, the IETF actually has a 3-stage maturity process, right? You've got proposed standard RFCs, draft standard RFCs, and standard RFCs. Very few standard RFCs actually make it to the full standard step. It's not required, right? And frankly, it takes a lot of administrative work to get past the proposed stage. The significant difference between propose and draft is that you have to have demonstrated implementation experience with two independently developed implementations that interoperate. Okay, so you have to write an interoperability report, right? That describes how every single facet of the protocol has been tested and proven to be interoperable. That's a lot of work. Not many people want to do it because, as I said, it's not required. But we did. And so 4 years after the proposed standards were done, we had the draft standards. That's how long it takes to get interoperability reports written in the IETF. It takes a while. Okay, but the good news is once the drafts were out there, the next step, going from draft standard to full standard, is a little less painful. And that one only took 2 years. Okay, but again, here's something I'm really proud of. When you think about how long the internet has been around and how long the IETF has been around, the IETF first started in the 1980s, so something on the order of like 30 years. There are only 92 standard RFCs, and we're up in the 5,000 or 6,000 range now in terms of published RFCs. So a very, very small percentage of these standards actually make it to the full standard state. But I set that as a goal for myself when I started this in 1999, and somehow again we managed to make it happen. All right, so EPP's out there, it's a standard. Well, that doesn't mean anyone actually has to use it, right? The neat things about IETF standards, they're not mandatory. It's about consensus building. And so you get vendors to buy into the party line when they see the value to them. And this is one place, though, where ICANN was actually very helpful. And again, remember what I said early on about the purpose for a client-server protocol, the agreement in language, right? You want the client and server to speak the same language so they can talk to each other. Now imagine you're ICANN and you're talking about turning on new TLDs and new TLD operators, and those new operators have to work with existing registrars. If you're a registrar, how do you think you'd feel if one day you got a letter on your door that said, "Hi, I'm your new registry operator, here's my protocol specification. Tell me when we can talk to each other"? I wouldn't be very happy, right? Because imagine as a registrar if you have to write a new implementation, a new interface to the registry for each and every registry. Okay, now imagine it's 2011 and they're talking about hundreds or thousands of new TLDs. This gets ugly fast, okay? But the good news, ICANN is mandating EPP for all new TLDs. Okay, now you might think, "Oh, that's great, we got one protocol problem solved." Not quite. Not quite. And we'll get to the why part in a minute. Well, here's part of the why part, actually. CCTLDs. They are not beholden to ICANN in any way, right? The country code top-level domains typically operate at the behest of some government entity within the country, right? So when ICANN says EPP, they can kind of say, "Yeah, ha, 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 no. We're going to do what we want." Right? And again, it kind of defeats the purpose of a protocol when some entities are using one mechanism, others are using something else. But interestingly enough, the CCTLD operators also tend to be businesses, right? Sometimes they're universities, but in many ways they're still concerned about reaching their consumers, all right? And when your consumers, the registrars, are all starting to coalesce around one solution, well, you either get with the program or you get left behind. So a number of CCTLDs, particularly the larger ones, have been using EPP these days. And a lot of the smaller ones are coming along just because everybody else is doing it. There's a lot of help out there in terms of open source software. There are people that have done this work. And as I said, if you want access to the registrars are saying, "Look, you talk to us using this protocol or you don't talk to us at all." Okay? So, why XML? Right? Back in 1999, when I was first looking at this, XML was a pretty hot topic. XML schema in particular looked really interesting because if you're familiar with DTDs and XML schema and whatnot, you may understand the difference in that XML schema gives you a lot more flexibility over specifying element syntax. So you can very specifically say that you've got strings of a certain length or arrays of elements and things like that. So when you're trying to come up with a formal specification language, well, you want to use something that actually is a formal specification language without leaving much open to interpretation. DTDs leave way too much open to interpretation. So XML schema was the hot thing. How do you get geeks interested in hot topics? Well, you use hot technologies, right? So we started using XML schema, and a lot of people were interested because it was this was the first enterprise-grade protocol work being done in the IETF using XML. So I had a lot of people looking over here just to kind of see what was going on. Well, how did we get the extensibility thing? You might think, okay, XML, the X part stands for extensible, but how do you actually do that, and particularly in the context of a protocol? And I apologize if this is a little hard to see, if you can see it all there, but there are a couple of different ways in particular. You'll see that we have element name definitions where we would say that we have an element that was named extension. So we had very specific places in the protocol where we would say, okay, this is the hook for an extension, and we used a type, a very specific type definition that said it's an extensible any type. And what this basically gives you is a hook where some other designer can come in and say, I'm going to plug a spot here, and then I'm going to define via my specification what this hook looks like. So it's a jumping off point from one protocol to another. Okay? We also used another type there called a service extension that uses extensible URIs. And so sometimes these extensions can be named using a URI. And that was another way to identify a very specific jumping off point. We ended up creating a registry within IANA for URIs to identify namespaces and a couple of other XML-related constructs so that there was some agreement on what the syntax would be. But here's a couple of examples. You can see what they kind of look like. This extensible any type, as you can see, it's an XML sequence, meaning things have to come in a particular order. But basically, by saying any other namespace and as many as you want, you could plug in hooks here. Right? So the other says, I don't care what it is, and max occurs unbounded means as many as you want. And similarly, the extensible URI type is just, give me a URI. It can be any type of URI. It can be HTTP. It can be a URN, and as many as you want. All right, I hope some of you are starting to think about this in the context, again, of one protocol, multiple registries, multiple registrars. How does this extensibility thing play in that context? All right. Realizing that extensibility is both a boon and a curse. There were two other little bits of related work that I took on when we did this early on. One of the first was writing an RFC, in this case a BCP, a best current practice RFC that describes, well, how exactly do you use XML and IETF protocols? Given that this was the first time we were doing it, a lot of people had some really wacky ideas. And we wanted to try to make sure that people who were working on extensions in particular, or other XML specified protocols, would try to stick to a couple of community agreed upon guidelines. So BCP 70, or also known as RFC 3470, was written by myself, Marshall Rose, and Larry Macinter. And that's stood the test of time thus far. No one's really pushed for it to be revised, so I think we did a pretty good job. But perhaps more importantly, in the context of EPP in particular, I wrote a document that was specifically focused on how do you extend EPP? These are the good things to do, these are the bad things to do. And that's RFC 3735. Okay? And as I mentioned a little while ago, we created this IANA registry for schemas and namespaces. But challenges abound. The problem with extensibility and the problem with trying to fit a protocol into a space where people have existing operations. These TLDs were operating before EPP came along, and they have existing business models, existing ways of dealing with their customers. Again, imagine trying to get 50 people in a room and saying, let's agree to one way to do this. It wasn't easy. We had to compromise in a lot of places. And ultimately, I can characterize the compromise as the core protocol is the minimum technical requirement stuff. Okay? Anything else specific to your business model? Extensions. Okay? At the time, we had 200 plus CCTLDs, right? New countries don't spawn up every day, so that number doesn't grow very much. But anyone who could look in their crystal ball could see the gTLD expansion thing coming. So we knew that there's going to be a need for more extensions in the future. Remember, part of the reason these TLDs exist is to differentiate themselves from other TLDs. The character string is only one part of it. A lot of times they want to add new features, new services. To do that in the protocol, extensions are needed. All right, and this last bullet, one of the big bugaboos. IETF coordination is not required to develop these extensions. Right? Nobody has to come to the IETF and say, I'm going to write an extension document, and here it is, people. So what you found happening, particularly in a number of the smaller CCTLDs, as people became aware of the protocol work, they said, oh, yeah, I can extend this. This is easy. Let me take this document over here, tweak a couple little things, and I've got an extension. Well, yeah, I mean, that'll work for your small little community. But what happens when things start to grow a little bit bigger? And again, when you talk to a registrar who wants to register domains in your CCTLD, and you say, well, here's my new little extension, and they kind of look at you and say, what the heck is that? Right? That makes no sense. So the coordination thing has always been a sticky wicket. All right, so now let's talk about some of these new operating requirements. Even back in 1998, when you had these 200 plus CCTLDs, we had differences in policy, differences in law, differences in business practices. Privacy laws in Germany are way stricter than they are in, like, the United States, for example, and they have an impact on the way the domain registration things work. Since 2000, we've introduced 13 new gTLDs. We know that there are more coming. And it became pretty clear early on that it's just impossible for one protocol to rule them all. So, how do we approach that? Okay, this is where the extension model plugs in again, right? We designed it that way from the beginning, so let's start using the extension mechanism to extend the protocol. But here's the problem again. The extensions have usually been designed by the registry operators in isolation. Right? They don't do it in the public forum, they don't ask for input, they kind of go off and do their thing, and then when the registrar comes knocking on their door, they throw it over the wall and say, here it is. So, as you might imagine, that presents a series of challenges. So now let's talk about, again, the registry-registrar protocol interfaces and how those fit into this scenario, right? We know that we've got some specifications defined in RFCs, right? But things that I like to call EPP-ish abound. And this is usually the case where someone takes an existing document, an existing specification, tweaks a couple of things, makes changes to a protocol. Right? What happens if someone changes a language on you when you're trying to talk? Does that work well? Right? Can you understand what people say when you go to Brooklyn? Right? In some ways, they've changed the protocol a little bit. And if you don't have a guidebook to translate Brooklyn into English, it's going to be difficult to communicate. And the same sort of thing was happening here. People were making changes, and in their little community it kind of made sense. But perhaps even more problematically, they would not change the protocol identifiers. EPP is identified via namespaced URIs that we register in these IANA registries. And so the machines that were communicating would look at these URIs and say, I think I'm talking to an EPP server because he gave me this URI that says I'm EPP. But then they would send back some other gibberish that made no sense. Okay, that's the EPP-ish thing. All right, so where are we in terms of extension specifications? As I said before, some are published as RFCs, and here's an example. RFC 4310, domain name system security extensions for EPP. Some of you have heard about DNSSEC, DNS security, recent hot topic in the DNS world, how now when you send a query, you can actually get back a response that's signed by the server so you know it hasn't been mucked with. Well, getting the keying information into the system required an EPP extension. Right? Because keys have to be exchanged between the zone operator who owns, for example, Purdue.edu. If someone ever wants to sign that zone, they have to take the keys for Purdue and push it to the operator of the edu TLD. We need an extension to do that. Unfortunately, many, maybe most, are not documented that way. And I know I've said this a bunch of times, I'm not going to beat it to death. Registrars work with multiple registries. There are non-standard implementations out there, one-off extensions, and custom development is often required when you're working with a new registry. So what happens when we're looking at hundreds or perhaps thousands of TLDs? If I'm a registrar, I'm thinking, uh-oh, this is scary. Okay, so how are we addressing these challenges? The good news is we've known about them for a long time. Right? So none of this is really coming as a surprise. One of the first things that people started doing was releasing SDKs as open source. So how do you make it easy for people? Give them software. A lot of these operators are small. I mean, if they are 2 or 3 person shops, that's large. And particularly when you're talking about trying to convince them from changing to whatever their existing system is to something new, one of the first questions is, well, what's the benefit to me and how do I do it? We talked about the benefit a little while ago. It plugs you into the larger registrar community, potentially opening up more customers. And how can we make it easier for you? We give you software. Okay? Registrars often, they use resellers too. Sometimes if you want to get into the business, but you don't want to take on the responsibility of becoming a registrar, and we talked a little bit about the accreditation process for TLDs, registrars have an accreditation process too. If you ever go to a website of a company like GoDaddy or Network Solutions, you may see a little icon that says ICANN accredited. They have to go through an approval process, there's an application process. ICANN wants to make sure that they're not putting their stamp of approval on a company that's going to take your money and go bye-bye. All right, so it's not easy to get into that space. Some companies have developed a business model where they said, oh, well, let's make it easy. We'll take on the accreditation responsibility, and then you can work with us. And we give you an interface that lets you register domain names through us. That's how Two Cows does business, for example. All right, and another important consideration is that, how many of you program in C? I'm not that old, right? Okay, so you understand what the size of construct returns, right? Okay, so the number of TLDs does not map directly to the number of registry operators, thankfully, right? As I said early on, Verisign, for example, operates a number of top-level domains. And as it turns out, a couple of the other larger registry operators do the same thing. In fact, one of the ways that Verisign, Newstar, affiliates make money is by offering back-end registry services to people who are looking to get into the TLD business. So as ICANN accepts applications from people for new TLDs, if you watch this space, you're going to see companies like Verisign, Affiliates, and Newstar partnering with other people. They've got an idea for a TLD. They don't really want to take on the responsibility of standing up the infrastructure to support it. They work with a company like Verisign to make that happen. All right, so by minimizing the number of registry operators, you minimize the number of interfaces, or the number of implementations that you have to work with. All right, and now most recently, there's been some renewed interest in this whole ICANN space within the IETF. And why that's important is because if you get a bunch of these people in the room talking to each other about how to figure out a standard way to do this, things do start getting written down. Okay? And then the implementers who are writing the code start to see that, oh, there is someone who's already done this. I can reuse that work. I don't have to go off and invent my own. But perhaps interestingly enough, when the topic of, EPP 2.0, I haven't mentioned the version number prior to this. EPP 1.0 is still the one that's primarily being used in production. And remember all these challenges I talked about? The extensibility, and EPP doesn't do that. We have to write custom extensions. So some people said, well, maybe we need to go back and change EPP. Maybe we need to start building some of these things into the core. And as we started looking at that, people looked at the problem and said, warts and all, what we've got is still probably the right solution. Because we're not going to be able to get back into the core and start adding one-offs that solve one person's problem but introduce problems for other people. Okay, so this most recently came up in 2010. The consensus opinion was, not yet. And I think part of it, too, is, remember, this took us 10 years. I don't think anyone wanted to say, okay, let's start the clock again, looking at EPP 2.0 and hope we're all still here 10 years from now. Okay, so that's how we're getting there. Before I step through the next slide, any questions, comments, thoughts? You're all experts now, right? Okay, so first question. Do you think EPP has met the challenge? I don't know if I've given you enough information to answer that question intelligently, but let's call that a rhetorical question, because I'm going to answer it for you. In some ways, yes, it has. It's the first enterprise-scale XML protocol specified in the IETF. It's been widely adopted and deployed. We clearly met the extensibility goal, right? No one has ever said, sorry, Scott, I can't do this. We've got 12 years of real operational experience. In pushing millions of transactions per day in the Verisigns.com infrastructure, for example. And as I said on the slide before, there's been no real compelling push for EPP 2.0. That sounds like success, right? Okay, but how have we not met it? As I say here, I think we met the extensibility goal too well. It's just too easy for someone to do something a little bit off the beaten track, and which makes it difficult for implementers. And if you make implementers' life difficult, they don't implement, right? Nobody wants to write the same code 5 different ways because we can't agree on one way to do it. So it's still very difficult for registrars to work with new TLDs and new protocol extensions. And given that there are hundreds, or I don't know about thousands, but there are clearly new TLDs on the horizon, this is something that people are really worried about. So we still have a lack of extension coordination and some duplication of effort. Right? Because we don't really have a forum in which people can talk about this stuff. One way this has been dealt with in the IETF and other contexts is the DNS. The domain name system has been around for almost 30 years. And while the core protocol work for the DNS was done a long time ago, you now have 2 IETF working groups focused on, well, what's happening right now? You've got the DNS operations working group, which is focused on, well, what are we doing day to day? What kinds of things can we do to keep it running reliably? And then you have a DNS extensions working group. So as people identify new needs, they have a place to come and talk with other people who have similar interests. One example, there's a working group called DANE. The focus of the DANE working group is to look at putting digital certificates in the DNS to see if they can't speed up the SSL handshake protocol. All right? You all familiar with how SSL works? Did you know that when you try to establish an SSL or TLS connection with a web server, the client is pulling certificates off of the server, right? That can take a long time, or relatively long. Or if you've ever noticed any lag between establishing a secured connection to a server and an unsecure version, I mean, is that humanly visible? Right? Okay. So imagine that there's a desire to try to minimize that lag by putting certificates in the DNS, and now that we have DNSSEC and those certificates can be delivered with data integrity, right? They're signed. You're guaranteed that you get back a certificate that's what it was intended to be, and you can pre-populate some cache in your browser with these certificates. Imagine how much more quickly that handshake protocol will work. Okay? So just one example. An extension, community of interested people, they're having some success. Okay, so now what? Where do we go from here? The focus really has to be on extension coordination. It's not going to be easy, right? Because we still don't have a venue for it. But I think the most telling fact is that when we looked at EPP 2.0 and people said, no, not yet, and we realized that this new gTLD expansion is coming, we as a community of people have to get together and start looking at this and maybe create a registry for extensions so that people start to actually know what's there and they don't have to worry about duplication of effort. That's the best thing we can do right now to minimize the amount of rework having to be done in the future. And I believe that's everything I had. So, not InfoSec focused, but I hope it was a topic that maybe some of you learned something about today. Any questions? Behind you, Bill. Sorry. Microphone on?
Oh, no, there's no mic up here.
Oh, okay, then I'll repeat your question.
My question was on the country-specific TLDs issues that you talked about. You said that, country-specific TLDs basically bring in certain issues in implementation. Could you probably give an example as how, the extensions help, not bring out that issue? Or probably any of the issue?
I'm sorry, I didn't...
No, as in the country-level TLDs, when there is an implementation, you said that they could specifically bring out certain issues which is not addressable or which could create a problem, and how the extension could actually, remove this issue that you come over. Probably an example or something.
Okay. Let's talk about, for example, the privacy laws in Germany. Okay? There's nothing in EPP right now that does anything for personal privacy. I take that back. There's one flag in the contact mapping. We do collect some personally identifiable information, right? If you're familiar with how the Whois system works, okay, there's a system out there where on your Unix server you can type, Whois, Amazon.com, and you will get back some identifying information that describes the registrant, the technical contact, the admin contact, the billing contact, and whatnot, right? So we have some very basic features in EPP that that let you say, okay, you can't disclose this to anybody, or I have something called a disclosure policy, all right, the DCP. But Germany's laws go far beyond that, and because they only exist in Germany, we didn't feel compelled to try to build that into the core protocol. All right, so the operators of .de have been writing their own extensions to deal with the local policies and the local laws, to make sure that they're in compliance with, with the laws of Germany. All right, now, maybe that's a bad example because I don't think those same privacy laws exist anyplace else, but if they did, and if the operators of .de were to publish their specification, someone else could, learn from the work they did and use that same extension. Does that answer your question? Okay, thank you. Bill, you had your hand up?
Yeah, I'm just wondering, you made a quick allusion to this, but how do you control things like, well, with biz, somebody coming in and grabbing IBM.biz? I mean, that I know was a problem in the very beginning.
Right.
And somebody had to adjudicate that.
Exactly.
Who did that? Who does that? And who
ICANN.
will do it?
ICANN does. ICANN has processes established, to deal with trademark issues. Now, in some cases, the TLD operators themselves have processes in place. They have sunrise periods, for example, where when a new TLD is launched, they will give registered trademark holders an opportunity to register domain names, that correspond to their trademarks. And there's usually a very extensive review period, for example, to make sure that it's really IBM who's attempting to register IBM.biz. Okay, those are the more obvious ones. The real problem happens though when something a little more subtle gets through, and eventually maybe a company like an IBM finds out that somebody managed to register a domain name that they feel infringes on one of their trademarks. ICANN has policies established where those sorts of instances can be reported, reviewed, and they actually have an arbitration board that renders decisions based on their findings.
There's a lot of other companies that have very similar names, though. There's Hobart Restaurant Company. There's I happen to know something about Hobart. So, and you might say, a lot of them are entitled to that. Is it in a case like that? It just has to be the first one who grabs it.
Yeah, and that's typically been the model. In cases where maybe there is no registered trademark, or the term is considered somewhat generic itself, first come first serve has always been the the first law of registration that way. Whoever got there first has it. Of course, if there is a trademark situation, being there first doesn't do you any good, and that's where the where the policy for being able to request a review and perhaps even having the domain name taken away from an existing registrar and handed over to the trademark holder exists. It has happened in the past. But I should say that is not something generally that the TLD operators themselves get involved with, at least not the gTLD operators. Country code, different situation. As I said, they operate under their own set of rules. You guys are letting me off way too easy. I'd rather answer questions than walk through slides, trust me.
Maybe we can thank the speaker.
Thank you.